Okay, yeah, hello everyone. So I'm just talking to you, as Simon said, about Encrypted Client Hello. So if you can move on to the next slide, please. It's not updating for me.
I've got how it works slide.
Yeah, I'm still seeing slide 1.
Anybody else? Are you seeing how it works? Which one?
You're not in presenter mode.
I am, but
Okay.
I'm definitely sharing.
Okay, I've got slide 2 now. So we're
I'll leave
talking
it there.
about TLS here. So, and of course, TLS is HTTPS, and ISP customers are using HTTPS for nearly every website. But the name of the website you're visiting is still visible at the start of every connection. So that name is called server name indication. And Encrypted Client Hello is a new standard being developed in the IETF to hide the true SNI for extra privacy. So it works by encrypting the sensitive name, and it just assumes that the name is sensitive. So you encrypt that sensitive name and you wrap it in an outer envelope that has a public name on it, such as that of the CDN that it's coming from. So by analogy, in a traditional letter, the name of the person you're writing to is visible on the envelope. Encrypted Client Hello still has that visible name on the envelope, but it's generic. So it just says something like Hosting Company London. But inside that envelope, there is a second envelope, which has the genuine destination name on it. So in the picture on the right, you can see the inner client hello is the destination you're actually trying to reach. So that is encrypted with a bit of data that comes from the DNS, and then it is placed inside the green outer client hello. So any network that is observing this TLS traffic, that is looking at the SNI, will only see the green public name. Next slide, please. So in terms of how it works, so it is a new extension to TLS. Even SNI itself was an extension, but this is a new one. So which extensions are in play are visible, so you can see when it's being used. But the aim here is not to stick out. So this will eventually be used by the majority of ISP traffic. Chrome have said they are intending to deploy it, and in fact, they're not even intending to create a setting that will allow clients to disable it. So whenever an ECH record is available, it'll get used. Mozilla have said that they are working on supporting it as well. So as I said, those details are published in an HTTPS record. Now, you may not be familiar with that because it's new. It's a new DNS record type that tells clients all the ways in which they can contact a website. So iOS 14 is already using it. And it's normally, currently it just says this website is available on these HTTP versions on this port. And Cloudflare, even though it's not standardized, they've already added support for those records across their base. Down at the bottom is what the HTTPS record currently looks like. If you use an old tool, it will look like gibberish, but it actually means the part in text there. ECH would enhance that record. So it would add the extra bit in red, which is ECH config equals, and then that will include both the definition of the visible public name and which encryption keys should be used to contact them and to do the encryption. Next slide, please. So what does this mean for anyone operating a network? Well, in terms of our customers, yeah, it's enhanced privacy for them. And it realizes the ambition of TLS that no man in the middle should be able to observe the significant details of the communications. You know, that's what TLS is supposed to do on the tin. Now, in terms of governments, Russia have actually proposed legislation that would make this illegal. And China's Great Firewall has been reported to be blocking the previous iteration of this ECH, which was called the SNI. So in countries where it is permitted or encouraged, you know, what else could it mean? So it will impact any parental control or other content filtering solutions that are based on a deep inspection of HTTPS. So those tools, if where they are, they will only see the visible public name, such as the name of the CDN. It also can reduce the effectiveness of customer support tools and network diagnostics that look at HTTPS. It limits the operator's ability to make certain traffic free of charge. So the NHS COVID-19 app, was the request is to make that free of charge, not so that people can use it as much as possible without needing to pay for that. Whichever the content provider is, it requires them to be willing to exclude themselves from ECH, or to use another mechanism to identify the traffic, such as static IPs. A couple of other impacts: it can complicate the ability of hotspot operators to whitelist content within the captive portal, and it can make enforcement of security policies such as blocking malware more difficult. Next slide, please. So in conclusion, BT looks favorably on new capabilities that enhance privacy and security for our customers. But while it certainly increases privacy, Encrypted Client Hello risks creating unintended consequences to customer experience and network support. So we are engaging with industry, and we welcome further industry dialogue on the optimal way of offering these new privacy features while still mitigating the customer network experience consequences. And if you go to the final slide, there are a couple of links on there for further information. That's not the final slide, that one is. Yeah, so if you want details of what ESNI is, what ECH is, the draft is called ESNI, that's in the top bullet point. Chrome's plans for actually developing the client are at that link. And that's it really. So yeah, open questions.
Thanks very much, Chris. And Tom, have we got any questions in the queue there?
Presently devoid of questions for Chris. I suspect theoretically at this point everyone would be waiting for beer. I'm not sure if that's still true in a virtual environment, but of course we have a minute or so if anyone would like to, if they're frantically tapping away at a question. I am literally checking all the monitors at the moment to see what pops up. So. I wasn't actually aware that ECH directly replaced ESNI. Out of interest, Chris, what was the reasoning behind that?
Oh, it was just puzzling over. Well, there was two parts. So ESNI was originally just an encryption of the SNI. It evolved to become an encryption of the whole client hello. So everything within it and whatever might be extended into it in the future. From that point, it was actually called Echo. And because of the name clash, it got shortened to ECH.
We have had a question through from Andrew Campling. Are there any plans for BT to deploy ECH in its clients, e.g. BT Sport, etc.?
So in general, BT supports anything that improves privacy, as long as we've been able to mitigate any of the problems that occur with it. ECH is still in development within the ITF, so it is any deployments yet are just testing. Does the concept work? Is it interoperable, etc. Once it is standardized, yes, it is certainly likely that it will be considered, but whether it's particulars into that particular application, I couldn't say.
Sure. Everyone seems to have woken up now. We have another question from Peter Hicks. If you have an environment where you have to actively filter outbound internet access in a corporate network, will ECH make this more difficult? And I think you may have alluded to that just now.
It does depend how it's done, I suppose. Actually, the Google Chrome product manager was addressing this point, and he said Google's view was that they expect all filtering to occur on DNS. And in a corporate network, if you've got DNS, there will be an enterprise DNS server, and it will, the clients will use it because they'll be managed clients, and they'll be told, no, you're not able to connect to that. But that is, of course, at the domain level only. And where you have an enterprise proxy that has root CA enabled, the question is, do you have to, if you're required to intercept all of the traffic to stop data loss prevention or something, it's good. It certainly helps to be able to do that selectively. So you can say, right, I'll look at the SNI. If it's this particular domain, I'll man in the middle. If it's not, I won't. ECH would prevent that kind of selectiveness. So it would require everything to be decrypted.
I know there's a comment there from Keith around DOE making DNS filtering impossible, although I presume that this leads into a lot of the work around discovery of encrypted DNS services as well. So those things are fairly related.
Yes. In terms of discovering DNS and DOH servers, it is certainly recognized by the major clients that enterprises are different, and enterprises need an ability to define which DNS server is being used. Okay. So I expect that to continue.
Grand. I think that's it for questions. Thank you very much, Chris.